Hello all, we're going to start with the unit technology here in this video lecture, and I'm hoping the sound quality is okay. I don't have access to my better microphone, so I'm having to rely on the microphone on the webcam in my office, and it's not usually quite as high in quality audio wise, but hopefully it's working out well enough for us. So here in Unit 3 on the physiology side, we're going to discuss the function of the skeletal system, which actually the skeletal system does a whole lot more for you than you might initially imagine. Of course, we're used to thinking about the skeletal system providing us with framework and protection, but it is also a storage depot for calcium, and as you'll see, calcium is extremely important for many different physiological functions in the body. So a lot of skeletal system function revolves around that. And then we're also going to talk about joints and how they work, the structure of joints, some different types of joint injuries and joint disorders that can develop. And joints, of course, are very important for everybody going into the clinical sciences, and especially you guys going into the physical therapy assistantship programs. All right, so our first little lecture here will be an introduction to bones. And I'm going to assume that you guys have already been working on the Unit 3 anatomy as I go through this, because that's actually, pretty extensive amount of material to have to learn for this body system. So hopefully you have already been working on that before you moved over here into the physiology side. The skeletal system, major functions, just kind of as a quick overview, and what it's composed of. The skeletal system includes your bones and cartilages. So we learned about cartilage, the different types, your hyaline cartilage, your fibrocartilage, your elastic cartilage, when we did chapter 4 on tissues, and we'll talk a little bit more about cartilages here in the skeletal system as well. Now, not surprisingly, the skeletal system provides you with a framework for the body, support, protection. Your rib cage is protecting all those really important organs in the thoracic cavity. The skull, of course, is protecting that sort of kind of important organ you've got up there in your cranial cavity. So those types of things are pretty obvious. But what may not be quite as obvious, storage of minerals, especially calcium. And calcium is usually written like this, calcium with the 2 pluses, or 2 plus signs like that, which just indicates that in our body fluids, calcium is an electrolyte. It's an ion with a double positive charge. Very important for many different aspects of bodily function. We'll hear a lot about it when we cover the muscular and the nervous systems. And calcium is so important that your body actually has to store it in your bones so that it can be harvested on an as-needed basis. So we'll talk quite a bit about it, quite a bit about that during this unit. Blood cell production. Back in Unit 1, we heard a little bit about this. The bone marrow, a type of marrow called red marrow, is actually the site in the body where your blood cells are produced, including your red blood cells and your white blood cells. So some people are not aware of that before they take a physiology course. And blood cell production, we won't hear a lot about that in this unit, because when you take Biology 202 and you study the cardiovascular system, you'll have extensive coverage of blood when you get to that particular course. All right, so like I said, hopefully you have been covering anatomy already by studying the skeletal system and learning all the bones and their features. I'm just going to briefly mention classification of bones by shape, because this terminology does come up off and on as you go through the physiology part of the course. Bones can be classified as long bones. And that's probably the term we'll hear the most as we go through the physiology. Long bones are simply, just as they sound, they're longer than they are wide. So, things like the arms in your bones, the arms in your legs, the bones in your legs, etc. Any bone that's longer than it is wide is considered a long bone. Now, they don't have to be big bones, so even the bones of your fingers and your hands are technically long bones as well, because they're longer than they are wide. All right, and so your long bones, oops, wrong thing there. Your long bones account for many of the bones in the skeletal system. Then some of your bones fall into the flat bone category, which, just as the name sounds, they're flat, not very thick, and so the sternum is an example of a flat bone. Many of the bones of the skull fall into that category as well. Then you have bones that are short bones. So short bones are going to be pretty similar in length and width, and there are several different bones in the body that are classified as short bones. Some of the bones in the wrists and the ankles fall into that category. And then finally you have bones that are called irregular bones. Those are like your vertebrae. These are ones which have kind of complex shapes, like you see there with that lumbar vertebra, and so they don't really fit into any of the other categories. So just be a little bit familiar with your classification of bones by shape. I can't say that that is the most critical topic here for Unit 3. But you do want to be familiar with that terminology because it does come up occasionally. Oh, another bone, another term I do want you guys to be familiar with, sesamoid bones. That's a special case where you have a bone that is embedded within tendons. All right, so tendons connect skeletal muscles to bones. Okay, and so a sesamoid bone is a bone that is actually embedded within a tendon. All right, and the sesamoid bone that everybody has is the patella. That's your kneecap bone. And now otherwise, though, individuals can actually have little tiny sesamoid bones that develop in some of your joints. For example, people who overuse certain joints, sometimes the soft tissues around the joint will calcify and form a sesamoid bone at times, but those are things that occur from individual to individual and don't necessarily exist in every person. The one sesamoid bone we all have, or the two sesamoid bones we all have, are our two patellae, our kneecap bones. All right, bone functions. These shouldn't be too surprising for you. Support and protection of vital organs, providing a framework for the body. Movement, levers for muscle action, that gets into your joints. So where your bones come together or articulate, bone articulations, where they make contact with each other or come very close to making contact with each other. Those are your joints, or where the bones articulate. And very often those are the locations where we have joints that allow movements, and those movements occur when your skeletal muscles pull on those bones and cause the bones to move relative to each other at those particular joints. And that's going to be, muscle contraction will be the subject of the next, or one of the major subjects of the next unit as we move on to that. Some additional functions, as I mentioned earlier, storage of important minerals, especially calcium. That's going to be the big one that we talk about here in Unit 3. Phosphorus is also stored in the bones. The hard consistency of your bones actually comes from salts that are formed from calcium ions and phosphate ions, and another type of ion called a hydroxyl ion, and we'll talk a little bit more about that shortly as well. Blood cell formation. All right, there's a term that you should know for blood cell formation, hematopoiesis. Hemato refers to blood, like hematology is the study of blood. A hematologist is a physician who specializes in blood disorders. And then a poiesis, whenever you see that term, refers to formation. So hematopoiesis literally means blood formation, and that takes place inside cavities or compartments inside some bones of the body that are called marrow cavities, or another term for that is medullary cavity. We'll see more about that shortly. And your bone marrow can be divided up into two types. So you have red bone marrow, and that's where hematopoiesis actually takes place. Yellow marrow is another type of bone marrow, which is basically, it has a yellow coloration because it's full of fat, so triglycerides are stored there for long-term energy. And we'll see too, as you know, when you're first born, you have quite a bit of your bone marrow is devoted to blood cell formation and falls into that red marrow category. But as you get older, more and more and more of your marrow converts over to yellow marrow for fat storage, and you have less of your marrow cavities devoted to blood cell formation. And you guys are probably aware, you've probably heard of somebody before who maybe had leukemia, a type of white blood cell cancer, and those cancers come from the red bone marrow because all of your blood cells are made there. So leukemia is caused by abnormal white blood cells, and sometimes the only way to cure that in some patients is to kill all of the blood cell forming tissue, the hematopoietic tissues in that patient, with radiation and or chemotherapy, and then they have to replace that with a bone marrow transplant from somebody who's well matched as a tissue donor, and then that transplanted red marrow winds up being able to recreate all of the different blood cells in the body. So you may have heard of somebody who's gone through that type of procedure before. That's a pretty drastic and dramatic thing to have to go through. Alright, so that's just a little quick introduction to the skeletal system function, and now we'll be covering different aspects of skeletal system function in more detail as we move through the additional lectures. The next one will be on bone structure, and really more so about what bones are composed of, what cells are there, the extracellular matrix of bone, and how these tissues are laid out in the different bones of the body. This will be moving through the next couple of video lectures.